Hello and welcome to Cisco Router Training 101. My name is Don Crawley from soundtraining.net. We're the Seattle, Washington-based provider of accelerated training for IT professionals. This time we're doing Understanding the OSI Reference Model. It's based on Chapter 2 in my book, The Accidental Administrator, Cisco Router Step-by-Step Configuration Guide. Not required for the video, but if you'd like to follow along, it is available on Amazon and through other resellers. You can get it through our website, bookstore, at www.soundtraining.net/bookstore. What is the OSI reference model? It's a 7-layer conceptual model developed by ISO, the International Standardization Organization, in 1984, and it describes the standards for intercomputer communication. In other words, how does the data get from one computer on one network across cables and connectors and wireless or whatever to another computer on another network? And that's what the OSI reference model attempts to describe. Now, there are 7 layers in the OSI reference model, and let's go over each one of them just to give you kind of a broad overview. First of all, we'll start at the very top at layer 7. That's the application layer. This is where you find network applications such as mail, web, file transfer, management through SNMP, remote connections such as with Telnet. Now, when we talk about applications, people immediately think of things like Microsoft Word or Outlook or PowerPoint, and those are the applications that would connect here if they needed a network connection. But generally, when we talk about applications, we're talking about network-specific applications, again, file transfer, web services, that sort of thing. At layer 7, the datagrams are called upper layer data. In fact, at the top 3 layers, they're all kind of lumped together, and the datagrams are called upper layer data. Layer 6 is the presentation layer. It provides a context for communication between the layers. For example, ASCII characters are described here. Also, you'll find encryption and decryption at layer 6. Compression happens here, and datagrams here are called upper layer data. Here's a way to think about the presentation layer, maybe to remember it. It prepares the data from the lower layers for presentation to the application layer. Next is the session layer, and it controls dialogues between computers. This is handshaking takes place here, for example. It also controls duplexing, termination, and restarts. Datagrams at the session layer are still called upper layer data because, again, the top 3 layers are kind of lumped together. Now we get into the transport layer. This is layer 4. It provides transparent transfer of data. Protocols that operate here are TCP and UDP. TCP for reliable connections and UDP for unreliable or non-reliable, maybe is a better way of describing it. In this case, non-reliable is not necessarily bad. It simply means there's less overhead because there isn't the error checking that happens with TCP, nor the confirmation of delivery. So you use TCP when you need to ensure that the datagrams arrive at the destination, and you use UDP when latency is more of an issue because there's more overhead associated with TCP. Good example of that is VoIP packets often will use UDP because they're more sensitive to latency than they are to packet loss. The transport layer provides end-to-end connections, also reliability, flow control, and the datagrams at layer 4, the transport layer, are called segments. Next, the network layer. This is layer 3. This is where routers operate. It provides connections between hosts on different networks. This is where you find protocols such as IPv4 and IPv6. I'm going to go over the different protocols with you in a moment, but those are 2 in particular that would be associated with layer 3. As we mentioned, routers operate here, so this is where routing of packets takes place. The thing to think about with the network layer is that first bullet. It says provides connections between hosts on different networks. If you're on the same network, then those connections take place at layer 2, but on different networks, it's layer 3. And again, the datagrams at layer 3 are called packets. Layer 2 is the data link layer, provides connections between hosts on the same network. This is where you find Ethernet operating. MAC addresses operate at layer 2. So IP addresses or IPv6 addresses are at layer 3. MAC addresses, sometimes called hardware addresses, are at layer 2. In fact, MAC is the acronym for the Media Access Control, which is a sub-layer of layer 2. And the datagrams at layer 2 are called frames. Finally, the physical layer. This is where we describe electrical and physical specifications for our devices. Our devices that operate here are cabling, connectors, hubs, repeaters, and the datagrams. Actually, we'll just say the data at layer 1 is simply called bits. Something to think about. When you're troubleshooting, you always start at layer 1. So when people say start your troubleshooting at the physical layer or layer 1, they're talking about the OSI reference model. You want to check and make sure things are plugged in, turned on, you have the right kind of cabling, the right kind of connectors. Now we've talked about the protocol data units, the names that are used to describe the datagrams at each of the layers. Let's just go over it once again. And if you're pursuing Cisco certification like CCNA, this is something that you'll need to know. At layers 5, 6, and 7, the datagrams are called upper layer data. At layer 4, the datagram is called a segment. At layer 3, it's called a packet. At layer 2, it's a frame. And down at layer 1, the data is called bits. So how does the OSI reference model actually work? Well, let's say the man in the picture on the left wants to communicate with the woman on the right. So he connects to the OSI reference model, and he sends a datagram down through each of the layers. And what happens is the upper layer data hits layer 4, the transport layer, where it's encapsulated in a segment. So the segment headers are attached to the upper layer data. Then it goes down to layer 3, where the segment is encapsulated in a packet. At layer 2, the packet is encapsulated in a frame. At layer 1, it's converted into bits, ones and zeros, and sent out on the network. Then it goes over to the other computer, the woman's computer, and it goes up through the different layers. And at each of the layers, the lower layer's encapsulation is stripped away until once again we're left with the upper layer data, which is then used to deliver the data payload to the woman's computer. The only time that there is actually a physical connection between the layers is at the physical layer, although sometimes people talk about how each of the other layers thinks that it's talking directly with its corresponding layer on another computer. But the main thing to remember is that the only time there's actually a physical connection is between the physical layers on each of the computers. Here are some of the protocols in the OSI reference model. This is not meant to be an exhaustive list, but it'll kind of give you an idea of the protocols that operate at each of the layers. At the application layer, again, you find the network protocols like Telnet, SMTP, HTTP, FTP, IMAP, POP3, and SNMP. Then going down into the presentation layer, that's where we find MPEG. ASCII characters are defined here. Also, transport layer security is defined here, as is secure sockets layer. NetBIOS and SAP operate at layer 5. TCP and UDP are found at layer 4. IPv4, IPv6, ICMP for things like ping, IPsec, ARP, address resolution protocol, and MPLS, multiple protocol label switching, operate at layer 3. Now, MPLS is a little tricky because it really lives kind of in between layers 2 and 3, so that's why I listed it in both layer 2 and 3. At layer 2, then was mentioned MPLS. Then there's RARP, reverse address resolution protocol, Ethernet, 802.11 and all of its extensions, PPP, point-to-point protocol, frame relay, ATM, asynchronous transfer mode, FDDI, fiber distributed data interface, fiber channel, all operate at layer 2. Then down at layer 1, RS-232 for your serial connections, DSL, 10 base T, 100 base TX, 1000 base whatever, those all operate down at layer 1, as does ISDN, T1, T3, and similar protocols. Now, how do you remember the layers? Well, here's a couple of mnemonics to help you with it. Going from top to bottom, first of all, APSTNDP, application, presentation, session, transport, network, data link, and physical, or all people seem to need data processing. That's kind of boring, isn't it? So let's flip it around. Let's go from bottom to top this time. So PDNTSPA, or programmers do not throw sausage pizza away, which is a truism if you've ever been around programmers. Just kidding. Sort of. Another way people remember it is people do not throw sausage pizza away, or please do not throw sausage pizza away. I hope that's been helpful for you. It's just a quick overview of the OSI reference model. There's lots of resources for you online, including at our website, www.soundtraining.net. You can also visit our bookstore at soundtraining.net/bookstore. I blog at soundtraining.net/blog. We've got video channel for you. I'll talk about that more in a moment. Also, you can follow us on Google+, like us on Facebook, and follow us on Twitter as well. As I mentioned, if you'd like more videos, visit our video channel at www.soundtraining.net/videos. If you'd like the companion book for this video, it's available through soundtraining.net/bookstore. It is The Accidental Administrator Cisco Router Step-by-Step Configuration Guide. As I mentioned, it's available through our bookstore or through Amazon and other channels. Again, I hope it's been helpful for you. For soundtraining.net, I'm Don Crawley. We'll see you next time.